Okay, these are the review problems for linear equations test. First problem is that the gradient of several lines is shown here. And we're going to pick out the gradients that are of lines that are parallel to each other. So if the gradient or the slope is parallel, that just means that they're the same. So let's try to pick out a couple pairs of numbers that are actually the same. Well, let's see, is negative 3, are there any other negative 3's? No. What about negative 5 over 2? Is there anything that's the same as negative 5 over 2? Yeah, there is, because here's negative 5 over 2, and here is 5 over negative 2, and of course those two things are the same, right? So these two are the same. What else do we got? 1/3. Is there anything the same as 1/3? No. 0.5. Well, 0.5, of course, is the same as 1/2. Is there anything the same as 1/2? 3/6. That's also 1/2, right? So those two are also um, parallel to each other. Okay, so those are the two for this, negative 5 halves and also 1/2. Now let's look at B. Find any two pairs of lines that are right angles to each other, which means they're perpendicular. Now remember that perpendicular lines have gradients that are negative reciprocals of each other. So for example, if I have a line that's 1/2 gradient, then the negative reciprocal would be negative 2 over 1. Okay, so that would be, let's see if we can find any examples of that here. Um, so how about these two? These two look like they're negative reciprocals of the other. Oh no, they're not, because look, they're both negative. Let's see, anything else? What about negative 3? Is there a reciprocal for that? The reciprocal for that would be negative reciprocal, so it would be positive 1 over 3. Oh, there we go. Okay, so those are perpendicular gradients. Anything else? How about 0.4? That's actually the same as 2 over 5. Okay, remember that 0.4 would be 4 over 10. 4 over 10, same thing as 2/5. Now, is there anything that's the negative reciprocal of 2/5? Yeah, this one. Negative, or 5 over negative 2. These are negative reciprocals. So I would put, so the two pairs are negative 3 and 1/3. And be careful not to put equal sign here, because they're not equal to each other. And I would put 5 over negative 2 and 2/5. Okay, so that's problem 1. Problem 2. These are 6 different sketches of lines, and they can all be described by the gradient intercept form. So the m in the gradient intercept form is the slope, or the gradient, and the c is the y-intercept. So just to give you an example of how that works is, let's look at this one here. So in this one, the gradient, if you tried to like estimate this gradient, is it a positive number or a negative number? Well, you can see that the run is positive if you consider it going to the right, but the rise is negative, so the gradient here would be negative. So for example, this sketch, the gradient is negative, right? So maybe we could just like first classify each one of these and put whether the gradient is negative or not. So you can see that like whenever you slope down, like this one, it slopes down, right? The gradient is negative, and when this one slopes down, well, this one slopes up, right? This one slopes down, this one slopes up, this one slopes up. So you can see by just taking a look at these real quick, you can tell that the gradient's going to be positive or negative if they slope down or slope up. Now what about the y-intercept? Is it that easy to see if the y-intercept is negative or positive? Yeah, it seems to be, because look, there's the y-intercept right there. Is that below the x-axis? Yes, so that means the y-intercept is negative. So this would probably be like, I don't know, -2 or something. So let's say it's C is negative. What about here? Is C, is that positive or negative? Actually, it's 0. What about this one? Is C positive or negative? It's negative. What about this one? C is positive, right? What about this one? C is positive. What about this one? C is 0. Okay, so now it's pretty easy to do this. Is M is positive and C is positive. Where do I see an example of that? That would be this one, right? So that would be L5. M is negative and C is positive. M is negative and C is positive. That would be this one, L4. Now M is negative and C is negative. M is negative and C is negative. That would be this one, L1. And last of all, M is negative and C is negative. That would be this one, right? No, sorry about that. That's wrong. M is negative and C is negative. Oh, wait a second. They wrote the same thing twice. That would be L1 again. I think they wanted to say something else there. Probably they wanted to say if M is negative and C is positive. No. M is positive. What they probably wanted to say was M is positive and C is negative. That would be this one, right? So they probably wanted to put L3 here. Okay. Okay, number 3. A student has drawn a sketch of L1 and L2, marked in the angles as right angles. Okay, but one of the lines is incorrect. Okay, let's figure out which one. So if L1 is y equals 2x plus 2, and L2 is -1/4 x plus 1, which one of these does not match? Well, we can use the same technique as we just did and look at the slopes and the y-intercepts and see if they're about right. For example, y equals 2x plus 2, is the y-intercept okay? Yep, 2. Y equals -1/4 x plus 1, is the y-intercept okay? Yep, it's at 1, right? So let's see, what about the slopes? Are they wrong? So for L1, it's a slope of 2, which would be 2 over 1. So the rise would be 2 and the run would be 1. Yeah, that looks correct. Now what about the second equation? -1/4 is the gradient. So the rise would be -1 and the run would be 4. Let's see. Run 1, 2, 3, 1, 2, 3, 4. The rise is -2. So actually this is what they drew was -2 over 4. -2 over 4. So this one's wrong. Okay. So, but they're asking us step by step here. So write down the gradients of L1 and L2 using the given equations. Well, this one's going to be 2. This one's going to be -1/4. Now, which of the two lines has the student drawn incorrectly? We already figured that out. It's this one, y equals -1/4 x plus 1. How can you tell from the answer to part A that the angle between L1 and L2 should not be 90 degrees? Well, if you look at the, from part A, that the angle between L1 and L2 should not be 90 degrees. Well, if these two lines were perpendicular, then we should have negative reciprocals here, and we don't, right? If a negative reciprocal would be 2 and -1/2, or 4 and -1/4, but we don't have negative reciprocals. So we can tell that they're not 90 degrees because not negative reciprocals. Okay. Draw the correct version of the incorrectly drawn line on the diagram. Well, the line is correctly crossing at the y-intercept of 1, but the slope should be negative 1/4 and not negative 2/4. So let's see, how would we draw negative 1/4? So that would be 1, 2, 3, 4. All right. And then it would go up 1. Let me change the color here so you can see better. So it would be this point, and it would be this point. Okay, so that's the correctly drawn line. Okay, one last problem in this video. So here's the equation of a line, and this line is perpendicular to another line called R2. So what's the gradient of R2? Well, we don't really know the gradient of R1 yet because it's not in gradient intercept form. So first, let's rewrite 2x plus y minus 8 equals 0. This form looks nice, but it doesn't really tell us anything. So we're going to put it in point intercept form, which would be y equals mx plus c. So let's get in this form. So y is already here. Move 2x to the other side. Move negative 8 to the other side. Okay, so we subtract 2x from both sides. We add 8 to both sides, and we get this. Y equals negative 2x plus 8. So the gradient for R1 is negative 2. Now what would be the gradient for R2? It would be the negative reciprocal, which would be 1/2. Okay. Now the point of intersection between R1 and R2 is 4, k. Find the value of k and the equation of R2. Well, we know that the equation of R2 is y equals 1/2 x plus something. We just don't know what the something is. So let's look at this equation. And we know that 4, k is a point on both equations. So we're going to put 4, k in this equation. So y turns into k, and 4 turns into x. So we're going to get k equals negative 8 plus 8. So k is 0. Okay, so the point of intersection is 4, 0, so k is 0. Now the equation for R2 we know is true for 4, 0, so we can put 4 and 0 in here. And then we get 0 equals 1/2 times 4 plus c equals 2 plus c. So 0 equals 2 plus c, that means c equals negative 2. So that means this equation for R2 is equal to y equals 1/2 x plus, minus 2. So that's the equation for R2.